So in this section we're in 2.2 reflections. All right, and this is in our chapter on what? Our chapter is over, you can kind of still see it on my board. It's over transformations. Okay, so transformations change a figure, change a figure into another figure. That can be done by translating that figure. Does anybody remember what a translation is? What happens when a figure is translated? Okay, do you remember, Sarah? Very good. It can be shifted, or we said it slides, right? It can slide left or right, up or down, but it cannot rotate and it cannot change in size. So that was a translation. Well, with reflections, what we're looking for specifically is if the figure flips over what we call a line of reflection. Okay, so this arrow that I've drawn is really important. Typically, the line of reflection that we're talking about is your X and your Y axis. Okay, so I want to practice our terms here right off from the beginning. Okay, based on the orientation, or basically what the line looks like, do you think this line on the graph would be the x-axis or the y-axis? What do you think? The x-axis. So what I'm saying here, this is kind of the proper way to say it, is that this figure is being reflected across the x-axis. All right? So that's just what we would say. If I was describing it, I would say it's being reflected across the x-axis, because that line stands for the line of reflection. All right? So here's why it's a reflection. All right? So we're just going to put it out there that this is a true reflection. And here's why. All right? So here's where you have to be a little visual. But if you were to take that top figure and literally flip it to the other side, this bottom right corner becomes the top right corner, right? If I were to flip it, and the top right corner now becomes the bottom right corner. And we can visualize that that is in the correct direction. If I were to flip it, now the line is slanting outwards instead of inwards. All right, so visually we can tell that it is a reflection. All right, now the challenge really will come into play is visualizing how the figure flips. Obviously, we're not dealing in 3D images on a test or a quiz, so that's where you have to kind of use your spatial reasoning skills to tell that, okay? So I would say that yes, this is a reflection. You don't necessarily have to say why, but you need to understand a reflection flips across the line of reflection, and it did do that. All right, everybody draw those figures and kind of identify the line of reflection too. All right, so let's look at the next slide. All right, the next slide has these crescent moons, okay? And now I would say that my line of reflection is across which axis? What is it? I heard it. It's across the y-axis. I know that because it's a vertical line of reflection, and that would be the y-axis. So again, we always want to think of it in terms of, you know, which axis it's flipping over. Okay, so now I've identified, yes, the y-axis is my line of reflection, but is it a true reflection? It might not be. All right, so I want you to answer that on your paper. If you think it's a true reflection, if it were to flip, all right, across that axis, is it a mirror image of the original figure? All right, what do you think, guys? What do you think? Yeah, it is, absolutely, because when we flip it, the points are pointing in towards each other. Yeah, it's a reflection. All right, we just say yes, it flipped. All right, now go ahead and draw this figure. And then tell me yes or no. Yes or no, guys? No, why? It doesn't flip. It's the same. What is it?
Translation.
It is a translation. It shifted. It did not flip. It simply shifted across the line of reflection. So I would call this a transformation. It's not a reflection. Okay? You see how they're going to kind of blend together, all these concepts? And on your quiz, that's what you'll see is a section of these figures, okay? And you'll have to tell me, is it a reflection, is it a rotation, is it a dilation, or a translation, all right? So you have to kind of have these identifiers so you know which one's which. All right, here's the last one that you don't even have to write down because is this a reflection? No. Why? Why is it not a reflection? Use your vocabulary. It
rotates, and I don't think that's an axis.
Okay. It is okay. So there's a couple things I want to identify here. Okay. It does turn. It absolutely turns, and it is actually a flip as well. It flips and turns, but it can only flip. All right. And the line of reflection is diagonal. All right. Now, you're not going to see this. Really, you're not going to see this very much in 8th grade math, but your line of reflection can be diagonal, okay? It just won't be the X and the Y axis, and that just gets a little more complicated than probably what we'll do this year, okay? But you can have a diagonal line of reflection, but you cannot have a figure that rotates. That would be a rotation, which we're going to learn, I think, tomorrow or Thursday. All right, so example 2. Here's really kind of the meat of the lesson, kind of just the same format that we saw in section 2.1, where we start off by just identifying, is it a reflection or not? And then in example 2, I'm going to teach you how to reflect a figure. All right, so what you need to know starting out is how to plot these points on the coordinate plane. All right, it's going to give you an original figure. All right, and that's what you see here is these ordered pairs. Those are negatives. It's just the font. All right, every point on this slide is very important. So I'm going to give you a couple minutes to write down all of these points. Okay, so take the opposite coordinates to reflect. Here's what that means, okay? So if I'm translating, oh my goodness, I don't like that word. Is that what they said in here? All right, no, it says draw a figure. Okay, we are going to change this word, translating to reflecting. Okay, reflecting. Sorry about that, guys. Okay, because that's what we're doing. It's a reflection. All right, if I am reflecting across the x-axis, I take the opposite of the y value, okay? If I'm reflecting across the x-axis, I take the opposite of the y value. If I'm reflecting across the y-axis, I take the opposite of the x value. Here's what it looks like. Here's your set of ordered pairs. Imagine if I were to graph them on a graph. You're about to graph one in just a minute. But imagine if I were to graph these, okay, and plot these points. I reflect it across the x-axis by taking the opposite y value, okay? So that way, if the y value was negative, now it's positive, so I'm crossing over the x-axis. So that's why you see that point A was -4, -3, and now I change it to -4, +3. I'm reflecting across the x-axis, so I take the opposite y value. All right, so let's look at B now. If B was -4, -1 in the original, I now keep my x value the same, but switch my y value. Now it's -4, +1. All I'm doing is whatever axis it's telling me to reflect, I do the opposite of the other value. Go ahead and try C and D on your paper and compare your answers with your table mate. Does anybody think they know what C is going to be? If I'm reflecting it across the x-axis and I have to take the opposite y value, what's going to be my ordered pair, Cheryl? -1, 1. Okay? Again, if whatever axis I'm reflecting, I take the original ordered pairs and I do the opposite of the other value. Okay, so what's D gonna be? Trey? Negative 1, 3. All right, so now on the second one, if I'm reflecting across the y-axis, that's why I see now that I'm taking the opposite x value. Because since I'm reflecting across the y value, I need to do the opposite of x. You see how it just kind of goes both ways? All right, and that's, guys, that's the easiest way to remember it. The easiest way that I can think of to remember it. Whatever axis you're reflecting, you do the opposite of the other value. Okay? So let's figure out B, C, and D. All right, so the coordinates are everything. Without coordinates, I don't know what to graph, so I have to come up with my coordinates. Okay, so what's B? What's B going to be? What's it going to be? Joshua, do you have B?
4, -1.
Very good. 4, -1, because now I do the opposite of the x value. I'm translating across y. Lily, what's going to be C? 1, -1. And D, Maya? 1, -3. And now I'm ready to graph. Okay? All right, and that's what we're going to do in the last example. Okay, so we're going to take some ordered pairs and we are going to graph them. All right, so go ahead and get out graph paper, please. We're going to do one graph. You can use 2.1 notes. You just need to make sure you label this 2.2 reflections. Since we're only doing one graph, I would probably just encourage you to do a new sheet of graph paper if you have it. Let's reflect. All right, so we're setting up our graph. All right, so that's what you should be doing right now. Please, please, please focus on your numbering, okay? Now, I have chosen to number every single unit. I know that that's kind of how you guys have been trained, and that's fine, okay? So label every single unit. If you want to label every other one, this is so important, and I'm still seeing mistakes here. You must skip blocks in between the numbers, because the skips, those are your odd numbers, and you should be able to see that based on how I've numbered it. Okay, so if you're struggling with that, just label every single one. It's not a big deal. We just need to make sure that we have these graphs labeled correctly. Now I've given you ordered pairs. P is 0, 0, Q is -2, 0, R is -1, 3, S is -4, 3, and T is 0, 7. It's rare that you'll have 5 points, but we do in this graph, and that's okay. All right, I need you to go ahead and plot each of these points. Make sure you label the points on your graph. Which one's P, which one's Q, which one's R. All right, let's go ahead and plot these points. Do not connect the lines yet. Okay, just plot the points. This is our practice every time, no matter if it's a reflection or a translation or the other two that we haven't learned yet. We always plot the original figure first, okay, before we really even worry about what's next. So that's what I've done here, P, Q, R, S, and T. Now, one thing I want to point out is there's a couple different ways, would you agree, that there's a couple different ways I could connect these points, all right? I mean, I could go from P to R to Q to S to T. I mean, I could do all kinds of crazy things. So how do I know where to go first? I follow it in alphabetical order. From P to Q, from Q to R, from R to S, and from S to T. And then once I get to the last one, I follow it back down to the first one. That's how I know how to connect the points. Now, most of the time, guys, it's going to be a triangle or even a four-sided figure, and you won't really have to worry about it. But if there's more than that, that's the succession that you would follow. You just go alphabetical. All right, so I've drawn my figure. Now I have to figure out how to reflect it, and here's how I do it. This right here tells me everything I need to know. I'm reflecting across the y-axis. So if I'm reflecting across y, I take the opposite of which value? Joshua? X. I do the opposite one. So I'm reflecting across y. So for each ordered pair now, I'm going to do the opposite of x. All right, so point P. Well, what's the opposite of 0? 0, so that one doesn't really count. Okay, for point Q, I'm reflecting across the y-axis. Guys, if that had said reflect across the x-axis, this would be completely different, okay? So that part's really important. So since I'm reflecting across y, I do the opposite of the x value in that ordered pair. What's the opposite of negative 2? 2. And I keep the y value the same, okay? You go ahead and fill in R, S, and T the same way that we just did the first two. All right, so what's R going to be? Just say it together. 1, 3. What's S going to be? 4, 3. And what's T going to be? 0, 7. All right, so what we're going to do, because two of these points are actually on the exact same location, is we're just going to draw a circle around that existing point and label it. If you have a different color pen or a highlighter or something that you want to draw your reflected image, you absolutely can. You can do it on a quiz, you can do it on a test, you can do it on your homework. All right, I'm all about that, okay? So let's go ahead now and draw the reflected image of this image, or of the original. So we plot our points. Everybody plotted your points? Okay, so 0, 0, 2, 0, 1, 3, and a really very simple way to check. Oh, and how do I follow my points again? What did I say? Alphabetical order. Okay, so don't mess that part up. It should be completely symmetrical. All right, and most of the time, if not always, you will see that the x or the y-axis is your line of reflection. Okay, at least on this level of math. As you get into the higher maths, you start seeing some different lines of reflection. But do you have any questions? Any questions on this, guys? All right, so that's reflections. All right, it's very new. It's very new. This is even the first time I've taught it in pre-algebra. So it's okay if you're still struggling. That's why we have the YouTube channel. You can go back and watch the lesson. Don't be discouraged. Just hang in there, ask questions, and we'll get through it. So we'll keep reviewing these concepts before we're quizzed and tested. All right, that's everything you need to know for section 2.2.